So we have two irregularly shaped objects we're going to measure. We're going to measure this key and this extremely valuable coin. And we're going to make use, you can perhaps see on the scale, we actually have these little hooks. So we can suspend from a wire the coin and the key for reasons that will become apparent in a moment. So I'm going to do that. So I now have the key hanging from the hook. This you'll see the reason for in a minute, but it's not actually in contact with the pan at all, so it's not having any effect at all on the experiment. And let's start putting our masses on. So I'm going to try 10 grams first. So 10 grams isn't quite heavy enough. I'm going to take 2 grams. Okay, so 2 grams is too heavy. Let's add on 1, so I've got a 10 and a 1 at the moment. That's not quite heavy enough. So I'm going to click the tenths of a gram up again, so 1. Okay, so that was 8 tenths that I added on there. And take your hundredths reading. So now you can see the key is actually suspended in water. It shouldn't be touching the base of the glass, and you can see it's just not, so that's pretty good. I actually had to do a little work retying the metal thread there. Now technically that might be a small source of inaccuracy because I did actually have to cut off a bit of the thread, but in practice the thread is so light and thin, you can kind of see it here. You can see I'm sort of dangling the thread there if I rock it back and forth. It's roughly as fine as Donald Trump's hair. So it's not going to make a big difference to the kind of measurement value that we get. So let's measure the mass of the key now hanging in water. And actually for this one, I've just put the 10 gram mass on. There's nothing on the tenths of a gram, and you can see it's actually balanced already. So I'm going to zoom in so you can see the scale, and that should give you the reading for the mass of the key in water.